Welcome to Climate Analytics Net channel. Today we will see spatio-temporal extraction of NetCDF data using GIS. When you see that NetCDF data format is a multi-dimensional data format. It contains latitude, longitude, time, variable or variables, and in addition to this, it may contains a pressure level. So, using GIS, how we can extract the NetCDF data either spatially or temporally. We will see now this. First, we should have to open GIS. After we open the GIS, we should have to go to the folder, and also we should have to have a data in the folder or anywhere on the desktop or any directory. Then we can have here the monthly NetCDF data, the monthly NetCDF data of precipitation. So we want to just plot spatial using GIS, this NetCDF data. What we should do directly, we can drag and drop to the table of content of the GIS. Now we can see that this processing. Then we can see that the spatial plot, what it looks like. There is also another mechanism to plot spatial data. This is the first mechanism. We can remove this, and also first what we can do, we can go to search tool, and then we can write here. We can write here in this box NetCDF. Then enter. Then you can go to make raster layer, make NetCDF raster layer. You can click here. Then input NetCDF file. Just you can click to this folder, and you can go to the directory, and you can get this ethshapes.nc. So you can click on here and open. It's processing still. Now just we can see that dimensions such as variable, x dimension and y dimension, just we can observe that the dimension values, here x dimension and y dimension, and including the variable values. So simply we can click here OK. Now we have got such type of plot. So when you can see that this plot indicates for us a spatial plot, but we should have to extract based on our area of interest. So here we want to extract this data based on the Upper Blue Nile Basin region. So to extract, we should have to get a shape file. Just the shape file is found here, UBN SHP, and there is shape file of the upper Blue Nile here. So we should have to go to this directory, just the plus sign, and we can get here to this directory, and we can click here and just add. Now we can make this white. The next step is extraction process. To extract the process, just we can go to spatial analyst tool. Then you can go to extraction and you can extract by mask. Double click here. Then we can select the layer, precip layer. Then input raster, that means that we are going to extract within a shape file. So we can call here, we can insert here the shape file. Then okay, the extraction process is started. So the extraction is completed now. We can see here. So here, what we can see here, this is the data which is extracted over the upper Blue Nile, But here we extract the data. However, the extraction of the data, basically, we should have to observe the year and the months, which month is more. We should have to work on it. So what we should do here, we should have to take this value and we can go and we can adjust the values here. The 9001981 data is extracted to check the year. If you want to extract any year, just you can change these values. You can change these values based on this. So you can extract. So what we extract now is 01011981 data, unlisted data we extracted. So now the next step is if you want, you can change the color. If you want, you can change the color. Okay, now the color seems like this. So next to this, we can see that we can click here layout view. Based on this layout view, we can insert the legend. We can insert legend here. We can next. If you want, you can do some adjustment on this. So this is a legend. So maybe if you want to increase or classify the legend, what you should do, maybe you can go here and maybe you can adjust some classification here, and based on the classification you can adjust also here based on your interests. So now we change the color here after we rearrange. I can select here this value. So the spatial extraction looks like this. Next, we can see that the temporal extraction. For extraction of a specific location, we should have to go to the tool, multi-dimension tool. Then you can go to NetCDF table view. we can click here. Then we can go to directly to that of the folder where the data is available. So we can have this data, we can click on it, open. Then we should have to insert the variable since we are going to extract the precipitation value. Just precip value, we can text as a variable precip, and you can go down and you can select here at time. Here you can select time and then longitude and latitude here. Latitude, longitude here. We can set the values here for latitude. Just we can put here 12 degree. For longitude, let's put 30 degree. Then simply we can say here, okay, now the extraction process is started. So the specific location extraction is completed here. Now we can see that this is table format, so we can open this table. So when we can open, we can see such type of results. You can see time here. The precipitation amount is observed starting from 1981 to that of the value as 0.05 to 2024. So that is longer data which we had got. Then if you want, we want to select all values. Then we can observe that there are, if you want to create a graph and many things you can do here, but our main interest is printing. If our main interest is just exporting the data, export. Then if you want to export to this, what you should do first, you should have to see the data format. Here is DBF. As I'm using DBF, here there are some options. Just we can click here, and also we can make here the GIS tutor, and just we can save. Okay. Maybe if you have interest, just you can say here yes. If not, just you can say that no simply. So we can see the result now here. Here we can see the result. GIS when you can open, just we can see such type of results. The last results which indicates the values of the precipitation for each month starting from 1981 to that of 05/2024. So one can see that generally in this tutorial we observe that how we can extract spatial the NetCDF data, and as well as for a specific location. So we will see the detailed part next time, how we can analyze the climate data so far. Thank you very much.